Okay, so in this section we're starting a relatively new idea. You may or may not have talked about it in Algebra 1. If you did, it was probably very briefly, but it's called piecewise functions. Alright, so what's the domain of the function? Well, just remember from earlier in the chapter, the domain is simply the set of input values. And typically we represent these using an x. So typically we use our x's. And what's a piecewise function? Well, a piecewise function is a function that's built on different pieces that are restrained by the domain. So the function is built in different pieces. Now, how do we evaluate piecewise functions? Well, it really depends on what the restrictions on the domain are. So we got to pay attention to the domain, and based on what the domain tells us to do, that's the piece of the function that we'll evaluate. So pay attention to the domain. That's the key. That's super important. And then how would we graph piecewise functions? Same thing, pay attention to the domain. So for certain parts of the graph, our domain is going to tell us to do one thing, and then when we get to other parts of the graph, our domain is going to tell us to do other things. So pay attention to the domain again. Super important for piecewise functions. So let's go ahead and look at an example. So it says evaluate when x equals 0, x equals 2, and x equals 4. Okay? Now, the way we read a piecewise function is first we need to look at our domain. So notice I got conditions over here. If x is less than 2, then I do this. I'm looking at this part of the function. If x is bigger than or equal to 2, then I do this. I use this bottom piece of the function. Okay? So it's pretty easy. So x is equal to 0. Well, 0 is less than 2, so I need to do this, x plus 2. So at x equals 0, f of x is equal to x plus 2. So I want to evaluate this at x equals 0. So f of 0 is equal to 0 plus 2, which is 2. So that means my answer, f of 0, is equal to 2. Alright, so now let's do the second piece, or the second question. Evaluate it when x is equal to positive 2. So at x equals 2, we need to go back and check our domain. So the rule for bigger than or equal to 2 says f of x is equal to 2x plus 1. So at x equals 2, we have f of x is equal to 2x plus 1. So now I can evaluate. So at f of 2, we have 2 times 2 plus 1, which is 5. So f of 2 is equal to 5. Alright. And then finally, for the last one, we want to evaluate when x is 4. So the rule for when x is bigger than 2 is still 2x plus 1. So at x equals 4, f of x is equal to 2x plus 1. So I'm looking for f of 4 now. So 2 times 4 plus 1 is equal to 9. So f of 4 is equal to 9. And that's it. Again, the key is paying attention to the domain, paying attention to which piece of the graph are you working on. Okay, because there's restrictions and you need to follow the rules. If you don't pay attention to the domain, most likely you're going to mess it up. Okay? So same thing here. Now we're graphing. Now this is a little bit trickier, okay? So what I like to do is I like to start with nice points. So, all right, well, I'm just going to plot a couple of nice points until I can get a picture of the graph. So the easiest, nicest point is 0, 0. So if x is 0, well, then I have to follow this rule. Or I have to follow this rule, less than 1. Okay? So let's make a table. So I'm going to color code this one. This is going to be in green. So I'm going to make my table for green. So x, y. So x is 0. We'll just plug in. Then f of x, or my y, is going to be 0 plus 3 halves. So 3 halves. X is maybe -1. So I have -1/2 plus 3 halves is +1. And obviously this is a linear equation, so that's all I really need. So let's plot these 2 points. So I have 3 halves, which is 1.5, so right here, -1, 1, right here. And so from less than 1, okay, less than 1, I'm going to have something sort of like this. And it's going to go all the way up to 1. And I'm going to do an open circle. It doesn't really look open right there. But I'm going to have an open circle right there at x equals 1, because this rule only goes up to less than 1. So it goes all the way up to x equals 1, but now I'm going to have a new rule. Okay, so my new rule says at x equals 1, at x equals 1, I have -1 plus 3, and I'm going to do this in blue. So over here, I'm going to make my table. Oops. So 1. So this is going to be +2. So let's plot that point. So 1, 2. So now I have a closed circle. It fills in this circle there. And then at 2, it's going to be +1. So now I can graph this point. I can graph this line, and it's something like that. And that's all it means to be a piecewise function. So you do pay attention again to the domain. Very, very important. Now, notice here the rule went all the way up to -1. I used an open circle, but fortunately we filled it in. It just worked out nicely that way. Sometimes it's not going to work out nicely where we fill it in. Okay? Let's try this one. Got lots of different restrictions. All right, so let's start with, well, x here lives between 0 and 1, so let's say x is 1/2. So x is greater than or equal to 0, so actually let's start at 0. So it's going to be 1. So greater than or equal to 0, and x is included. Well, we go all the way up to +1, and we're going to draw an open circle. Now at +1, we go to the next rule and jump up to my y value is now 2, so I'm going to do a closed circle here. Go all the way across an open circle. And I make another jump. Closed circle. Go all the way across like that. And then finally the last one, when x is equal to 3, x is equal to 3, the y value is 4. So that's included, and we go all the way up to 4, but 4, x equals 4 is not included. Now, you might look at this and be like, hey, that's kind of interesting. That's an interesting pattern. It is a function because if we do a vertical line test, since we have an open circle, only covered up one piece right here. This is an open circle, so there's nothing there. So there's only one piece covered up, only one piece covered up, only one piece covered up. So this is a function. There's exactly one output for each input. There's exactly one y for each x. The x's do not repeat. So this is called a step function. And this is used a lot, like when you're when phone companies bill your minutes for how long you talk on your cell phone and stuff like that. Okay, and now we want to write an equation for this piecewise function. Okay, this is a little bit strange too. So we want to take it one piece, literally, at a time, and find the equation of the line. Once we have the equation of the line, then we're going to worry about restricting it in the domain. Okay, we're going to be like, well, if x is less than 0, then we're going to do this line. If x is greater than or equal to 0, then we're going to do that line. Okay, so let's go ahead and get started. So I'm going to look at this left line first. Well, my y-intercept for the line is given. It's right here at y equals 2, so this is b is equal to 2. And I can use that point and this nice point right here to find my slope. So I go from left to right, so I go up 2, and I go to the right 2. So remember, my slope is just a change in y over the change in x. So my slope is 2 over 2, which is 1. So for this line, this line right here is y equals 1 is equal to x plus 2. Okay, I'm not worried about restricting it right yet. Now, if I don't restrict it, it's going to keep going on forever. We're going to take care of the restrictions in just a moment. Okay, now I'm going to come over to this line. For this line, the y-intercept is 0, and I can use this point to find the slope. So I'm going to go over 2 units to the right, so plus 2, and then 2 units up, plus 2. So my slope, the change in y over the change in x, is equal to 1. Okay, so for this equation, y is equal to x plus 0, or just y is equal to x. Now, if we continue this line on forever, it would keep going on down, but now we need to restrict it. So let me add a page so we can do that. Here's our picture of what we just talked about. Okay, so over here, I'm going to write our function. So we have f of x is equal to, and I'm going to do our bracket. Now, we have our 2 equations, x plus 2. Now, this is going to be like our y equals. So all I need to put in is x plus 2. So x plus 2. So y equals x plus 2 if, now we need to look at the domain. This function right here, this line is valid only when x is less than 0. If x is less than 0. Now we go to the other part. Y equals this line, y equals x, if, now we need to put our restrictions using the domain. Okay, so we go from 0, 0 is included in the domain, and we go all the way on, so x is greater than or equal to 0. And that's it, that's our answer. That's how we write the equation of the piecewise function. Okay, and we want to go back to single page, sorry about that. And that's it for piecewise functions.